Hello, this is your captain speaking. Please turn off all electronic devices, place your seat and tray tables in the upright position, and fasten your seatbelts. Welcome to the Interior and Passenger Accommodations video. We will discuss the MD-80 interiors while comparing them to the Boeing 737-800. Today we'll be talking about seating, passenger electronics, air conditioning, oxygen system, cargo storage, galley, lavatories, and exits. We picked the 737-800 because of the similarities in layout, size, and capabilities. Here are the comparisons of specifications for each aircraft. The MD-80 series range from 130 to 172 passengers per plane, whereas the Boeing 737-800 holds 162 to 189 passengers. The MD-82 at the Stillwater Airport seats 156 passengers. The top right image shows a schematic of the MD-80 series, while the bottom image shows the 737-800. Notice the MD-80 has 5 seats in a row, and the 800 has 6. The image on the right shows the cross-section of the fuselage of the MD-80. The average seat width is 18 inches, but for most of today's airlines, the average seat width is 16.5 inches. The major differences in the MD-80 and the -800 are 5 versus 6 seats in each row and the seat width. Since the MD-80 series was built, seats have generally become smaller and thinner to accommodate more passengers. Multiple onboard electronic systems are necessary to maintain a pleasurable flight for all passengers. An auxiliary power unit generates electrical energy to subsequently power electronics inside the aircraft. In terms of passenger equipment, this includes cabin lighting, in-seat electronics, and the possibility to charge personal devices via power outlets on newer aircraft, such as the Boeing 737-800. Lighting in itself runs on 28 volts DC, as is common for commercial aircraft, and is present throughout the cabin via overhead, galley, and floor lights. Passengers possess additional control of the reading lights placed above their seats. In order to maintain desirable air properties during flight, it is necessary to control the temperature and pressure of cabin air. 2 air cycle machines deriving bleed air from the engine's 8th cycle are primarily responsible for this effect. At this stage, the air is hot and at a relatively low pressure and is exposed to ambient ram air in order to cool it. A centrifugal compressor then compresses it further, which causes internal temperature to rise up to 600 degrees Fahrenheit. Heat transfer with another ram air heat exchanger produces cool, high-density air. At last, the air goes through a turbine. This turbine cools the air by expansion and derives work to power the centrifugal compressor. After leaving this stage, the air must be dehumidified in order to achieve desirable properties. While this additional water was once discharged overboard, new aircraft such as the 737-800 fleet spray it inside the ram air heat exchanger side in order to increase the efficiency of heat transfer. From left to right are the heat exchangers, turbine, and water separator subsystems of the air cycle machines on board the MD-80. After being brought to ideal conditions, the cold air is partially mixed with the cabin air in order to achieve a desirable supply temperature. It is subsequently supplied to the cabin occupants via a supply system ending in a series of eyeball-type sockets above the seats. The cycle is repeated when the air gets warm and is mixed with the cold air coming in from the air cycle machine. The delivery system is here pictured in both schematic and 3D form. A cabin outflow valve regulates the cabin pressure such that it remains at a level suitable to the occupants, typically 10 to 14 psi. A manual valve designed to the same effect is also controllable from the flight deck. In case of cabin depressurization, an oxygen system is responsible for the life support of the flight crew and passengers. The flight crew is serviced by use of a high-pressure oxygen cylinder delivering oxygen to individual masks inside the flight deck. In contrast, each seat and lavatory in the cabin is fitted with a dispensing unit which drops from the ceiling and starts generating oxygen once activated. Chloride is used as an oxygen source via a chemical reaction occurring inside the generator tank. This reaction is exothermic and therefore necessitates heat insulation in the form of a heat shield in order to protect the passengers from accidental contact with the hot surface. The mask automatically drops from the ceiling once the cabin altitude exceeds 14,000 feet or under 8.6 psi. The components associated with the passenger oxygen system are here detailed in schematic and picture form. The MD-80 has 1,253 cubic feet of cargo capacity with overhead compartments able to support 90 pounds of stowage. Towards the front of the plane, a place for hanging suits or wheelchairs is available. The top image shows the current compartments for the MD-80. The bottom image shows the future of overhead cargo storage able to hold 6 suitcases. The MD-80 has 3 underbody storage compartments. All compartments have the ability to circulate air for pets, while only the forward compartment is heated. The MD-80 galley is divided into 2 subsections located forward and aft of the occupants. Their purpose is to provide cabin attendants with collation, refreshments, and kitchen utilities in compact form. Each subsection comprises a door in order to allow for external access and restocking. The first 2 pictures from left to right display the forward and aft galley section inside the MD-80. The last image shows the Boeing 737-800 galley, which is very similar to former designs. There are 3 lavatories on board the MD-80. Toilets with blue water use Anatech Blue SFTY100, a chemical that disinfects and unclogs the toilet. The Federal Aviation Administration mandates that all airplanes have ashtrays, although smoking on planes is illegal. This is to prevent passengers from putting cigarettes out in the paper waste bin. Vacuum flush technology now eliminates the need for chemical toilets. Boeing is also working towards self-cleaning lavatories. Outside the plane, service ports are located for potable and lavatory water supply. Along with the front and aft service doors, there are 4 emergency exit doors highlighted in the orange circle. Highlighted in the blue circle is a tail cone exit door for emergencies, but it is rarely used. The Boeing 737-800 has similar exits except for the extra service door in the aft of the aircraft. The red arrows indicate all exits. Notice the emergency exit seats in the middle of the aircraft have extra legroom.